We did the unit circle by Sarah, Philpott, and Shannon Whalen. The unit circle deals with the 6 trigonomic functions. The 6 trigonomic functions with right angles, radians, sketching and finding coterminal angles, and degrees. The unit circle deals with sine, cosines, and tangents, which tangents are in blue, and sines and cosines are in red. Now that we've explained the unit circle and their degrees are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and ending with 360 degrees, because a circle equals 360 degrees. So, and all the other degrees is in between. The 6 trigonomic functions deals with sine, cosine, tangent, cosecant, secant, and cotangent. Sine equals y and cosine equals x. With that in mind, we're going to try A, which is pi over 6, which can be found right here on the unit circle at 30 degrees. So to find sine, we have to find y. So sine y would be 1/2, which means sine pi over 6 equals 1/2. To find cosine, which is x, which can be found right here on the unit circle, it's going to be cosine pi over 6 equals square root of 3 over 2. Now to find tangent, it's going to be tricky, because it's going to be y over x, which is sine over cosine. So tangent pi over 6 equals 1/2 over square root of 3 over 2, and you have to flip and multiply to get your answer. So it's going to be the square root of 3 over 3. To find your cosecant, it's going to be 1 over sine or 1 over y. So cosecant pi over 6 is going to equal 1 over 1/2, because 1/2 equals sine, which is going to equal 2. Secant is going to be 1 over cosine or 1 over x. So secant pi over 6 equals 1 over square root of 3 over 2, because the square root of 3 over 2 equals cosine. So it's going to give you with your final answer, which equals 2 square root of 3 over 3. And last, you have cotangent, which is going to be 1 over tangent or x over y. So to find cotangent pi over 6, you have to do x over y and flip and multiply, which gives you square root of 3.
Now for B, we're going to do pi, which is located right here on the unit circle. Note, with doing pi, you're going to hit some zeros, and there's no division by any zeros. The zeros can happen at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And there you can see pi, which we're doing in this problem. So you start out with sine, which is y. So you go up to the unit circle and see that y equals 0. And then cosine, which is x. So you go over to the unit circle and see that that is -1. Next we have tangent, which is y over x. So it equals 0 over -1, which you can see up there, which equals 0. Cosecant, which is 1 over sine, or 1 over y, equals 1 over 0, which is undefined because, once again, there's no division by zeros. For secant, it's 1 over cosine, or 1 over x, which equals -1. And for cotangent, which is 1 over tangent, or x over y, is also undefined because you cannot divide by 0.
Next, we're going to do problem C, which deals with finding sine, cosine, and tangent on the unit circle. So we have to find pi over 4 first. There's pi over 4 at 45 degrees. So now we have to find sine, and sine, as we've already said, is y. So to find it, we have to point to y, x and y. So it's going to be square root of 2 over 2 as our answer. So cosine is going to equal x. So we refer back to the unit circle, and it's going to be square root of 2 over 2. So that's cosine. And last but not least, tangent, which is y over x. So tangent is y over x, giving you sine over cosine. So it's going to be square root of 2 over 2 and divided by the square root of 2 over 2. And you have to flip and multiply, which is going to give you 1.
Next, we're going to do finding the 6 trig functions once again, and we're going to use 3 pi over 4. So you start out with sine, which is y, and you can find 3 pi over 4 right here, and y is going to be the square root of 2 over 2. Next, we want to find cosine, which is x, which will go back to the unit circle again, which is negative square root of 2 over 2. And then we go to tangent, which is x over y, and that equals, for 3 pi over 4, equals the square root of 2 over 2 over negative square root of 2 over 2. You need to flip and multiply, and it equals negative 1. For cosecant is 1 over sine, or 1 over y, which is 3 pi over 4, which equals square root of 2. For secant, it's 1 over cosine, or 1 over x. For secant 3 pi over 2, you're going to get negative square root of 2. For cotangent, which is 1 over tangent, or y over x, and for that, for 3 pi over 4, you're going to get the square root of 2 over 2 over negative square root of 2 over 2, which gives you negative 1.
Another part of the unit circle, as we said before, was the 6 trigonomic functions with right angles.
So you start off with your functions, which is sine, which equals opposite over hypotenuse, cosine, which equals adjacent over hypotenuse, tangent, which equals opposite over adjacent, cosecant, which equals opposite over hypotenuse over opposite, secant, which equals hypotenuse over adjacent, and cotangent, which equals adjacent over opposite. Note that during this, the functions in the second column above are the reciprocals of the corresponding functions in the first column. As you can see, these ones are flipped. Now, where we get these opposite and hypotenuse and adjacent sides is over here on our right triangle. Here you have the opposite side, down here you have the adjacent side, and up here you have the hypotenuse.
With that being said, we're going to try to find the values of the 6 trigonomic functions, which, as we said before, are sine, cosine, tangent, cosecant, secant, and cotangent. Now, notice that my triangle over here is 4, over here is 3, and hypotenuse does not have an answer. So in order to solve this, we need to use the Pythagorean theorem, which is hypotenuse squared, which equals opposite squared plus adjacent squared. So to start off, we need to use the Pythagorean theorem and find hypotenuse. So given the other two values, we squared them and put them in the equation, giving you hypotenuse squared equals 4 squared plus 3 squared, which is, you're going to add your squares together, giving you hypotenuse squared equals the square root of 25. The reason, use the square root sign to take away the square on hypotenuse. So therefore, it'll give you 5. So now we add the 5 to the hypotenuse. So we can take it back and find sine, which is opposite over a hypotenuse. Going back to the square, it's going to be 4 over 5, as we said. Cosine's adjacent over hypotenuse. Referring back, it's going to be 3 over 5. Tangent is going to be opposite over adjacent. And in order to do this, you have to do 4 over 5 divided by 3 over 5, which equals 4/3. Cosecant is hypotenuse over opposite, which is going to equal 5/4. Secant is going to be hypotenuse over adjacent, which is 5/3. And cotangent is going to be adjacent over opposite, which is going to equal 3/4.
Next we have B, which we're going to be looking at two different triangles, and at the end we're going to be trying to say why they are a little bit the same. Now with this, we're still going to use the Pythagorean theorem, but it's going to be a little bit different because with both of these, we have our hypotenuse and our adjacent, but we are looking for our opposite side on both of them. So we're going to start out with the big triangle, which is right there, and it's going to be 10 squared, which is the hypotenuse, 8 squared,